I would like to speak about drinking water, actually about nitrate-polluted drinking water. This is not a problem in the remote areas in the developing countries. It is everywhere. In most cases, it is evident in agricultural areas, and especially if there's intensive livestock. The polluted of the nitrate is percolating very slowly through the soil, which means it is here to stay. The pollution we experience today is a result of previous decades' acts, so the worst is yet to come. Even if we miraculously stop polluting, which, as we know, we don't. Nitrate pollution is strongly linked to different cancers and other diseases. And unfortunately, the research has shown that it is linked to much lower levels of nitrate than the current standard, a standard that we often not comply to. Let's look at the numbers. These are official numbers issued by the European Commission. If you're living in a big city, most likely you don't have a problem. There are central reverse osmosis systems that are taking care of the pollution, and there's less pollution to begin with. But if you live in the rural area, 84% of the water that you are drinking is coming from groundwater, and the pollution is much, much bigger. 65 million Europeans, especially in these rural areas, rely on 85,000 small drinking water suppliers, of which 33% of the reporting ones are not compliant with the current standards. But most small suppliers are not even obliged to report, so it is anyone's guess how many people are actually drinking polluted water. The current available technologies are separating rather than treating, so they generate brine which need to be dealt with. But in any case, these are suitable for central, large area, large cities, etc., but not for the agricultural areas with small villages and cities. And it is very, very energy demanding. Our technology, the Zero Nitro, is a phytoremediation-based solution, usually not known for accuracy and reduction of nitrate. But the Zero Nitro is very different from other phytoremediation technologies and is suitable for exactly to do that. It is actually solving both the problems, those of the small communities, but also treating the brine of central ones. But I would like to concentrate on the small communities in the rural areas because those are the ones that currently don't have a solution. So we have a phytoremediation system, but it is an algorithm-controlled system which is cost-effective. It removes 98% of the nitrate, but it does not remove essential elements for human health. It treats rather than separate, so we don't have any brine. It has a positive carbon footprint and very low energy consumption. This leads to a very cost-effective system, and as you know, money talks, especially in small communities. But Ofra Aqua is a small company, and the demand and the need is huge. So how to go about this? It is obvious we need to further develop and protect our algorithm and our designs. But we want the technology to be open for implementation to any water engineering company, any place on the globe. So this leads us to investing in online courses, manuals, and support to allow a worldwide impact and to really give a solution to all these people that currently don't have that. Thank you very much.